Someone was asking about these general purpose smoke detectors that are sold on eBay, and they're quite widely sold from China and well, here in the UK they're sold by lots of UK sellers. And the price from China starts at about £2 for a smoke detector, and if it is an ionization technology smoke detector, that's quite impressive. But let's take a look and we'll see what it's actually like, if it seems okay inside. So it comes with a couple of screws for mounting, handy. Says photoelectric smoke alarm, which is not an ionization one. Okay, it does come with a battery. Is there a device for stopping you putting it up if there's no battery in? No, there's not. There's usually a wee device here that stops you putting it in, if probably something that's designed to pop up here, and I'm not 100% sure they'd do that if it's ever really been designed with that in mind. But let's stick the battery on, and actually let's just open it. That's what we came here for. These things are usually just held together by these little plastic clips at the side, and this one is no exception. Oh, I like the way the LED here under the button has a spring over it. A potentiometer, that's quite odd. And the little test button. The battery supplied it with is not an alkaline, that's not so impressive. If you get one of these smoke detectors, if they're any good, we'll soon find out, then let's test it. Let's stick the battery in and blow some smoke into it. I can tell you for a start that it does look like an optical detector, because the ionization ones usually have a small piece of radioactive material, and the way they work is there's basically two plates, and a piece of the radioactive material creates a sort of ionization path between them, and that allows a very small current to flow, and when smoke blocks those ions, the ionizing radiation from the emitter, it reduces the amount of current that can flow, and that's how it senses. Optical ones, if this is an optical one, and it looks like it, usually have a sensor pointing one direction, a source pointing another, and then it's arranged so that external light, smoke can get in but external light can't really get in, and the sensor can only see the beam when it's actually there's smoke particulate in the air. So let's connect this up and see what happens. Nothing, let's press the test button. Oh, that works. Okay, let's blow some smoke into it and see what happens. I'll put my finger over the sensor so you don't get deafened. The sounder, should I say. The LED has started flashing very quickly, as if it's gone into some sort of pre-alert. Oh, there it goes. I'll blow that clear. Is this going to go off? And back to normal. Okay, right, let's open it up. It works. That's a good start. We wouldn't all be dead by now. So I can see some clips here which don't go back very far. There we go. Okay, not surprisingly it's based on a... Oh, it's beeping still. Oh, it seems to hold quite a modest charge. Not surprisingly, it's got one chip doing everything, which is an XC5010DW. And underneath it's got, in capital letters, AVF, small letter A, capital letter Y. So AVFAY. I'll look that up later on. So let's open the chamber and just see what's... I presume this clips together in some way. I'm kind of getting deja vu that Julian Illett also checked a smoke detector out on his channel recently. I wonder if it's the same one. Because I remember him opening a plastic chamber, but his had some sort of like a perforated strip round it. I shall provide a link to his video down below, just for comparison purposes. Okay. This is an optical unit. That looks like a infrared sensor by the fact it's black. It's got the filter on it to filter out ambient casual light, you know, white light. It's got quite a complex pattern here of little tunnels so that no external light can come in to interfere with it. And it's got what looks like, I'm guessing that's an infrared LED. Let's power it up and see what happens, if it is visible or not. Oh, look. It's detecting that something's wrong. Is it because it's seeing... Oh, right, okay. That must be because, of course, it's seeing the light coming in from the side. Okay. We'll tell you what then, let's pop that LED... you know what? If this is an infrared LED, let's swap it for a visible LED and see what's happening. So, if the beam is shining across that way, apart from the channels that stop the light coming in here, there's also this little barrier here that's also designed to deflect light so that the sensor can only see the actual particulate in this area here. And it can't see a reflection of this directly. And the surface of the plastic is textured on both sides as well to stop it being reflective. I wonder how much light actually gets through from one side to the other. I'm sure that some reflection must occur. This potentiometer is quite intriguing. The sensor has a little component across it. A 270k resistor. What about the LED? There's a transistor that's going to drive the LED. And a resistor of value 8.2 ohms. Which seems quite low actually. And there's a little capacitor next to it, unless it's dumping that capacitor through. I wonder if the capacitor has some sort of... Oh yes, yes, I see it. I see a little resistor there, which is 1k. So that may actually be charging this little capacitor here, and then this transistor dumps that capacitor through the LED to give a sharp, bright pulse. Okay, the soldering iron is up to temperature. Let's desolder that LED and we'll stick a visible one in instead and see if we can see what's happening. So just push that out. Is that going to hike out yet? It seems to be clipped into that housing quite well as well. It's out. Right, I'll clean up those pads and we shall solder an LED in. Yeah, I think I'll re-tin those with proper lead solder and then suck the solder off them, because it works better than that despicable lead-free solder that I tear into all the time, because it deserves it. Getting there. Almost getting there, completely messing up here. That's it. So let's find a suitable LED. What have I got? Here's a warm white LED. I wonder what the polarity is of this. The little capacitor that dumps through has the negative connected to there, which is being switched through the transistor, so that's positive there. Oh, it is marked on the PCB, so let's solder that in temporarily and see how often it pulses the LED. Put this lid back on just so it doesn't get upset at the lack of light. It'll be looking for darkness. Oh, that doesn't actually go on terribly easily now. I think that LED may be fouling it a little bit. There we go. Right, let's take a look at that LED. I don't know how bright it's going to be, because my guess is it just pulses it very briefly. It pulsed 2, 3, 4, 5, 6, 7, 8, roughly every 8 seconds. 4. That wasn't the correct pulse. That wasn't. Oh, that's pulsing faster now. And of course it's beeping. I wonder if it detects that. I wonder if it detects that the infrared's missing. I wonder if it's not just a fixed threshold, but it's got an amplifier that detects that there's something amiss. That, you know, that it can detect that when there's no smoke there by a very slight reflection infrared, and then the stronger reflection from smoke. Yeah, that's unless the battery's flat. I don't think the battery's flat, because it's a brand new battery, and not that it's a great choice of battery. Let's measure the voltage. 10 volts. It's a very fresh battery. Okay. I wonder if it's detecting that something's wrong. I'm going to have to see if I can find a data sheet in this. I shall be back shortly. Okay, I drew an absolute blank on that chip. However, when I looked at the circuitry in the back and then looked for something similar online and did a search for photoelectric smoke detector, and just did an image search for the schematics and typed in some random keywords, I discovered that the chip appears to be a clone, or maybe it's just rebadged, of an MC145010. And that's the 5010 is the clue here, because that was part of the numbering on this chip. And this is one sophisticated little chip. This is clever. It does detect, it's got different gains that it can detect when the infrared source, when there's no smoke there, it will see a very slight reflection from the inside. So if that fails, and actually when you press this button it also tests it, that if you press the button it's actually doing a test to actually see if it can detect the flashing, the infrared LED, which then flashes at a faster rate corresponding with each beep. And also it detects, it only beeps if it's detecting it being seen, so that is an actual test if this chip is implementing it correctly. Other things, the LED flashes while it's in normal operation. It does roughly one every 8 seconds, but every so often I noticed it was putting an extra one, and that extra one was to detect, it was a test. It was actually testing maybe about once every half a minute. It was doing a quick high gain test just to see if it saw the infrared flash bouncing off the inside the chamber without any smoke. When it detects smoke, it goes into a sort of pre-alarm mode. It starts flashing, and it also starts pulsing the LED faster and sampling faster. And then, obviously, well, we saw it, it goes into the alarm mode. And after that, it keeps sampling until it sees the smoke's gone down. The circuitry is quite interesting. Obviously it's got all the things like the sounder driver, and it's got the ability with an I/O pin to couple up to other units, so you can connect them all with the sort of, I think it's the ground and the I/O pin that's sort of short circuit protected, so that you can couple loads of smoke detectors together. Let's see, what's the quiescent current? Quiescent current is about 12 microamps. Going up during the peak, it will go up to a couple of milliamps, but only just very brief pulses of that. The schematic, there's the pattern of pulses it puts out. It drops in these chamber test pulses in amongst the standard infrared pulses. So these ones here, these extra beats if you will, are the little extra tests. It also only strobes the infrared sensor. It doesn't keep the infrared sensor circuitry active all the time. It just strobes it every time it fires a pulse from the LED. I think it may also strobe it when there's no pulse in the LED, just to get a comparison in the background. Very sophisticated little chip. Let's see, where's the schematic? So there's the detector, and it does show a resistor across it, the infrared detector, and it shows the potentiometer there. In a mid sort of point of potential divider. There's the infrared drive, is switching that transistor, which does shunt the LED. It charges this capacitor here. I'm guessing that is 100 megafarad, like it says here. Yes, it is. And it's got the 1K charge resistor, so it is pretty much textbook copying of this. Yeah, it's interesting. It's actually a lot more sophisticated than I thought it was going to be. I thought it was going to be something fairly dumb, that, you know, it would just be like a simple op-amp detecting the reflection if it exceeded a certain level. But it doesn't. It seems to sort of compensate to a degree for aging of the unit with slight contamination inside, and it can differentiate between, you know, just increasing contamination or even degradation maybe of the LED and the actual smoke detection. And it seems to have the facility to put alarms out if it's, you know, do its sort of pip noise if it's detecting that something is going wrong. So yeah, that's quite interesting. It seems to be a genuine detector for your measly £2. I guess that's just down to mass production. So yeah, that was actually quite fascinating. I spent a lot of time playing about with this there, just that little gap in the video there, and going to find that data sheet, which really took me a long time to find. But if you search for the MC145010, then you'll find this datasheet PDF quite easily. The one I got, I downloaded from Farnell, which is a fairly large electronics supplier. But yeah, surprising. Actually, it's not the ionization one like it says in the box, but having said that, oh, there's another thing. The ionization detectors seem to be going out of favour with the fact that these seem to detect smouldering fires a lot quicker than the ionization ones, which need quite a modest amount of smoke. Now, These ones are very good at detecting the large particles that come when a fire is starting and it's emitting quite a lot of smoke because it's just smouldering. Those larger particles are much easier to detect in this than they are in the ionization detector, which, you know, that small number of large particles will be detected by this, but the ionization detector, the ionization will still find its way around them. So the Opto seems the way to go, and well, I'll let you make your own judgments on whether you'd trust something for £2 from China, but if it's a fairly generic design and it's got these test facilities actually built into it, then yes, it seems quite a reasonable smoke detector.